we are gonna do another question, which is the number of vectors, minimum number of vectors in different planes, that can be added. Um, so let's write can that can be added. So different planes that can be added to give zero resultant is. So if you watched my previous video, the only thing that has changed is that it's gone from same plane, so coplanar, to different plane. So the answer changes. It's not going to be 3 anymore. And we're going to talk about why it's not going to be 3 anymore. If, like, let's say the answer is 4 and the answer is actually 4. If the answer is actually 4, that's going to be the minimum. And also 5 can also give the same answer. That's also a thing that you must know. But if 4 can give, 5 can give, 6 can give, and so on, for special cases, of course. So now let's see all the cases what we can do. So what I'm going to do, I'm going to make a vector. So let's start from one vector, and we will move on to why each case is possible and each is not possible. So let's say we have only one vector, right? So if we have only one vector, if it's not zero vector, or it doesn't have magnitude of 0, it's never going to lead you with zero resultant. So resultant is never going to be 0, right? The magnitude of the resultant is never going to be 0, since it's never going to be cancelled. Let's say you have two vectors. If you have two vectors, let's say the first vector can be kept in any way, right? You can keep it by in any way, and as long as it is exactly opposite and same in magnitude. So let's copy this. So this has the same magnitude as the white vector. Let me change the color to make it so white the white vector. But if it is rotated and it is placed like this, it's always going to lead you with zero vector, so zero resultant. So this is the only case where you'll find the resultant is 0. So the resultant is going to give you 0. But if you check out over here, they are coplanar. So they are coplanar. Also, they have the same magnitude. So the magnitude are same. So same magnitude. So we have this. Now let's check out with three vectors. I'm going to do this in another page, since I think we need two drawings. Let's say we have three vectors. Let's copy this. There are a few ways of this happening. I'm just gonna make it longer, so the first way is to cancel it out. So let's copy this and just cancel it out. So what do we mean by canceling out? If you remember, in two vectors we canceled it out by doing this. But the thing is that we don't really need that there to be a single vector like the blue one. We can make so that the resultant leads to the blue one, but individually there are different vectors. So let's make this vector, right? So this vector. So as you can see, the blue and the green one is going to cancel out the white one very exactly. So this is going to lead you with resultant to be 0. As you can see, the plane is still same. So coplanar. Also different magnitude. And another question that you might have is, can they be of the same magnitude? And yes, it can be of the same magnitude. The figure might not be exact, but I will try to show you what I'm trying to tell you. So let's rotate this and let's make it red. So let's show that this is, if there was a vector, let's say if there was two vectors and there was the vector like that, that could exactly cancel that out. But I'm going to make it dotted line, which means that this is a vector that is caused due to a resultant. Let's copy this and put this over here as well. So you can know that this red vector is caused by these two vectors. So these two vectors lead to form that vector that will cancel that out. So to see how this can be formed out of same sized vectors, you just need to take this vector. Let's rotate it, trying to not change the size. The size might change because I'm not that perfect on drawing this, but you can make it so that the size does not change. And I'm not gonna be that precise, but you can understand what I'm trying to say. The length are equal, but the only thing that has changed, if you have to say that, it's the direction. So let's take that. Yep, that works. Let's make it dotted. So let's make it orange in color. Let's make it a normal line. Let's also make it a dotted line, and let's make it a lot smaller. Let's make this blue. Let's make this green. So over here, when I have three vectors, so I only have three vectors. The red one is the resultant that you will get. So it's technically not there, and it's technically there if you don't include this vector and this vector. So in this case, you will have a resultant that is 0, which is still coplanar, and which has same magnitude. Okay, now let's talk about different magnitude in three vectors. In two vectors, we are sure why it is not different magnitude, since you need exactly something that cancels it out on the opposite direction. But in this case, can there be a case where it is in different planes and it leads to the same result? And that is no. The simple answer why is that just think of make any three vectors with your hand. Like you can take your thumb, index finger, and the middle finger and try to make any three vectors in different planes. If you make them, there will always be a resultant that comes out from between them. So any case that you do, that's going to give you a big problem. That's why it does not work. But let's see why four vectors work, and I will also tell you more about why this does not work in the four vectors as well. So let's say we have four vectors, right? So we have four vectors. So let's just make three vectors first of all. Let's copy that. Why should we waste it? And this is gonna be hard to show since this we are not in this is a plane, so the screen you are seeing this in is a plane. And what you can think of this, I'm going to make it so that this looks like a XYZ coordinate system. So this is going to be the XYZ coordinate system, right? um, so you can think of this as a XYZ coordinate system, and they are exactly in different planes, right? So let's say you had these three vectors as in a different plane. Then if you make your hand like in that shape, so you can make your hand go in that shape. So that I will draw the picture. So your hand like this. So if you make your hand like that, you will see that there is a vector that will come out as this in the result. So I'm just going to make that right now. So let's just copy this, and it will come out. The length might be something like this, I don't know, but if it's pointing out of the screen, it will look something like that, right? So it's not actually smaller than these vectors. It's just that it looks like it's smaller since it's coming out of the screen. This is like a perspective trick, if you can think about it like that. Just make your hand like this, and if you think of a resultant, the resultant is gonna be around here. But the thing is that when you're looking at it from the front, it's not gonna look it's gonna look a lot shorter than the other ones. The longest one that you're gonna see is different. So we have this. So this is gonna be the resultant out of these three vectors. But in actuality, there aren't these four vectors. So I'm gonna make this with a dash to make sure that you know that this is a resultant out of these three vectors. And I'm also gonna make this is the resultant out of this vector, and that vector, right? um, and this resultant is from this vector and that vector. So we have this resultant, and to cancel this resultant out, which is this is a simple thing to do. The simplest thing to do is to rotate it by 180 degrees. So let's rotate this. Can't really rotate that well, but I'm just gonna try to do my best. So I think we can do maybe this. Yep, we can do that. So this is a vector that is going into the screen, like it's going inside. So that's why I'm telling you this is like very hard to tell in words and also express in a diagram. So this is gonna look a lot shorter actually. I think this will look something like, okay, let's make this come out a bit more, and it will look something like this maybe. um, Not the best. I'm not gonna say not the best drawer, like I'm pretty good, I think so. But it's really hard to explain to you when I'm drawing it. But just think about it. If you have three, like make your fingers like that, and let's say that the result is always going to come up from the this part, and you have to think of a vector that goes outside of that part. So it's exactly canceling out. And when you get over here, each of the four vectors are in different planes. So each of them are in the different planes. It's just that this third vector, this vector, the resultant that you get from these three vectors is in the same plane as the purple vector. But the white, green, blue, and purple vectors in itself are in different planes. So let me just tell you again. The white, blue, green, and purple vectors are in a different plane, right? So they are in a different plane. And if you want to make them, so I will draw a hand. So I think looking at a hand will be much more easier. So let me just copy my hand. That my hand looks like that, like that. I will use another page. Okay. Uh, my hand looks something like this, this, yeah, and I think this, the hand kind of looks like this, right? So if you have this hand, let's say this is the first vector, so I'm gonna copy these three vectors as well, so you can have a you can do what I'm trying to tell you. So let's say that's the first vector, that's the second vector, and that's the third vector. So I'm gonna rotate it to make it something like that. So the resultant, I'm just gonna take this resultant, but you know what I'm trying to say. The resultant is gonna come something out of the screen. So it's gonna come out of the screen. You're gonna see it come towards you, which is something that I can't. So that's why it's very hard to tell you about it. But just think about this. If you have another finger, you can put your finger like this. So that will be the direction it's coming out of. And if you have to cancel that vector, you have to be exactly opposite to that direction. So that will be this vector. So this vector might look small. It's because of perspective. So that's what I'm trying to show you. But it's actually the same length as this. So think about it. So if you have your finger, the thing that you need to cancel it out is going to be on the back, right? So I'm not going to put that. I'm just going to show you that. So that's what I'm trying to show. I think that was pretty clear. And if you still don't understand it, this is I have no I have if I were to teach you this in real life, I think this would be much more easier to explain, since you can actually look at your hand and I can point it out how it's gonna be cancelled. But I think you can still think about it. So put your finger like that. You're gonna see where the resultant is gonna come out. The resultant is come out from something from the middle, and it's gonna come towards you. And since it's gonna come towards you, you're gonna cancel it by going exactly behind it, right? So that's what I'm trying to say. So you get that the resultant is 0. It's different planes, so none of them are in the same plane, none of them are the same plane. And the magnitude can be you can do anything, so it can be any magnitude. So you can make it so that all of them have the same magnitude, and you can also make it so that they do not have the same magnitude. It's up to you how you do it. So um, on the basis of the angle that you have the vectors in, the magnitude that you have and magnitude that you get is different. So in this picture, it's not quite clear what magnitude I'm trying to do. It looks like everything is of the same magnitude, but I can be sure I'm not sure. So I think this is the answer. So I think you should have a pretty clear idea on why it is 4. So if you did not understand this, I guess watch other videos. I don't know, or you're dumb. Like one for two options. Even if you're dumb, like no offense, but um, I'm pretty sure you can learn this. Like just try hard. Not try hard. Just please continue learning. Like if you just learn random things, it does not have to be anything related to your course, anything related to what you like, anything related to what you dislike, anything. Like even if you learn anything, someday in life you will actually, if you keep on learning. So if you stop learning, that's a different thing. But if you keep on learning in life, you will find that things that you watch for fun sometimes it becomes useful. That's most of the thing that I've learned. Like I watch YouTube a lot, and most of the videos that I watch are for education content. I when I watch them, I think that I'm never gonna use them, but I find cases where I have heard that word, or I have heard that term, I have heard that equation. So this is a very useful skill. That's why I recommend you to keep studying, even if it's for fun. Like learn for fun. You don't need to remember any equation. You just need to know the theory, and must love the theory. You must be with the theory. You can learn it as slow as you want, as fast as you want. It does not matter. Got kind of philosophical in the end. Not trying to be that philosophical, but it's fun to have these parts in some of these videos as well. I guess in the far future, I hope that someone is gonna watch the whole series and they're gonna get here and they're gonna be like, yeah, right. So this is it for today's video. On the next video, we're gonna do another question. So yeah, that was it for today's video. Bye bye.